Okay, so let's look at some examples of sums of divisors. So where do you think we should start?
But at the beginning with like 2 or 1.
Okay, let's start at the beginning. Which could be where?
Could be 1.
1. Okay, so the divisor sum is
Just 1.
okay. 2. The divisor sum is
It's
3.
3.
3. 3. The divisor sum is
4.
4. 4. The divisor sum is
Get
7.
7. 5.
6.
6.
It's 12.
Yeah.
12.
7
7.
is 8.
8. 8 is
15.
9 is 13.
and 10.
5 is 18.
18.
Mm-hmm.
You agree?
Yeah.
It's 1, 2, 5, 10, yeah, 18. Okay. So this is tricky. Do you see any patterns in these numbers?
Well, the only thing that I can see just looking at it is the primes are always 1 more than their number.
Okay, that's good. So p goes to p plus 1.
Yep.
Okay. Do you see any other patterns? There's at least one other clear pattern inside of these numbers. The primes is a good one.
Well, we have powers of 2 go to the next power of 2 minus 1.
Ah, very good. So 1 is a power of 2. It's 2 to the
0.
goes to 2 to the 1 minus 1. 2 to the 1 goes to 2 squared minus 1. 4 goes to
7.
2.
2 cubed minus 1.
8
Goes to 2 to the 4th minus 1.
Okay, that's interesting. Can we say anything about the powers of 3?
Oh.
3 and 9. 4 and 13.
Okay, so we had 3 went to, well actually 1 is a power of
Yeah.
3. 1 went to 1. 3 went to 4.
9 went to
9 went to 13. What does 27 go to?
So it's 1 and 27, and then 3 and 9. So 28 plus 12. So it looks like it goes to 40.
Okay.
4, 13, 40. So
1, 4, 13, 40.
3,
Well,
3, 9. Well, it adds. So we have
Yeah.
plus 3 plus 9 plus 27.
Okay, that's an interesting pattern. Plus 3, plus 9, plus 27. Why is that happening?
So when that happens, we get. So we're basically we are adding. Basically, when we go from this to that, we're just adding another divisor.
because the sums, you can write the sum. Because the divisors here are just powers of 3.
Okay.
So you can write this is 1. This is 1 plus 3. This is 1 plus 3 plus 9.
Yeah.
This is 1 plus 3 plus 9 plus 27.
Okay.
So that's why you're adding the next power
Yeah.
on.
All right. So that was a great thing to notice, and we can understand why that's true. But now we're going to try to figure out a formula for those numbers. What do you think that formula would relate to or could relate to?
Well, you could, like the nth power of 3 would. Well, you can't really can't really say just sum up both these.
So are we calling this the first power of 3 or the 0th power of 3?
Well, what did we do with 2? What was our rule with powers of 2?
So with powers of 2, so let's say, 2 to the...
Powers of 2, sorry,
Yeah.
am I still on camera here? Is my mic
Yeah.
Sideways. Powers of 2, they went to, the sum of the divisors was what?
It was 1 less than the next power of 2.
So, I guess 2 to the n went to 2 to the n plus 1, and then minus 1.
Okay, so good. So 2 to the n went to 2 to the n plus 1 minus 1. So what you asked, is this the first power? So this would be number 1.
So-
what is it actually?
It's 3 to the 0.
Okay. Well, yeah, with 2, it was 2
Yeah.
to the 0. So we should probably consider this if that the powers of 2 tell us to probably consider that to be 3
Yeah.
to the 0.
So it looks like 3 to the n is gonna be
3 to the n is
is gonna go 3 to the it's gonna be 3 to the n plus 3 to the n minus 1 plus 3 to the n minus 2 all the way down to plus 3 to the 0.
okay. That's right. That's a good sum. So 3 to the n is 3 to the n plus the sum of divisors 3 to the n minus 1 dot 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 all the way down to plus 1. That's it. That is absolutely a formula for it. Now, can we find a simpler way to say it? Because that is just literally the definition of the sum of the divisors.
Well, I'm seeing another pattern.
Okay, yeah, what is
So,
it?
You have 3 goes to 4, 9 goes to 13, 27. So this is plus 13 plus 4 plus 1. So you take the number before, so you have 4, 9 plus 4 is 13.
Oh, good.
27, 13 goes to 40.
Yeah?
I think that's the same
Right?
same kind of thing.
No, but that's good. You're saying 27 plus 13 is 40. 9 plus 4 is 13. So you take the sum before.
Yeah.
And your brother's right. That's just because we're adding a new divisor.
Yeah.
So powers of 2 went to 1 less than the next power. So can we relate powers of 3 here?
Well, the next so here the next power is 2 away. Here it's 5 away. Here it's 14 away. And then here it's 41 away.
Okay.
But there's not a pattern
We have
with how far away you are from the next power of 3.
Okay. So
so if we did the next one, we'd have 40 plus 41 is 81.
okay.
So you might be some number and then some number plus 1 equals the next one.
Okay. So
Cool.
here, so we had 2 to the n. The sum was 2 to the n plus 1 minus 1. And we're looking for a formula. Simple formula with 3 to the n.
Well, I see. No, that's it. Well, it works with. It looks like it works with these two.
What?
So if you multiply your result before by 3, and then add 1,
Okay.
you get to here. And then if you multiply by 3 and add 1, you get to here.
Aha.
But it doesn't work. Well, I guess we don't know that yet. Because we don't know the sum. So 81's divisors actually does work. It does work. If you multiply 40 by 3 and then add 1.
Okay. Let's go to the next video and we'll keep proceeding.